In this section P.5, we're going to be factoring polynomials. So the first thing we're going to begin is factoring out the greatest common factor from a polynomial expression. So for the greatest common factor basically represents the highest expression that can be divided from a set of terms. Okay. So in this particular problem, we can see that all of these terms can be divided by, the highest number that they can be divided by would be 7. So that would be my greatest common factor. But not only 7, since all of them have x in common, then that means that we can also factor x's from this expression. The maximum number of x's that can be factored is x squared, because this last term doesn't have more x's to give. So we're going to factor the 7x squared from this polynomial. We're going to factor it out, meaning we're going to put it on the outside, and then inside of this parentheses we're going to write what's left from this polynomial if we take out that 7x squared. Now the easiest way to determine what's left is we just have to divide the 7x squared into all of these terms of the polynomial, and if I do that, then 7x to the 4 divided by 7x squared is going to give me x to the second power. Now one thing about division is that when you divide two variables, you subtract the same variable by itself, you subtract the exponents. That's called the quotient rule, which we're going to cover in a later section. Now minus 14 divided by 7 is going to be 2, x cubed divided by x squared is going to be x. Then plus 21x squared divided by 7x squared is just going to be a 3. And this is the factored expression. Next thing that we're going to factor is we're going to use an application of greatest common factor, which is factoring by grouping. Now usually I just want you to keep the following in mind. To factor polynomials by grouping, it is usually done when we have a polynomial with 4 or more terms. That is the main idea right here of when you're going to use this process of grouping. Okay. Now let's go ahead and begin with this problem right here. Factor the following expression by grouping. Now this process consists of the following. First thing you got to do is you're going to put this expression into two separate groups. So I'm going to put these two terms in one group and the last two terms in another group. Now what you are going to do from each group is basically what we did in the previous question, which is we're going to take out the greatest common factor from these two numbers in this group and take out the greatest common factor from these two values in this group. Now the greatest common factor from these two is that we cannot divide the 5 and the 2 by any number other than 1, but we can take out two x's. So it's just 1x squared. That's all we can divide. So we're going to take out the x squared from this expression, and what we got to do again is we're going to divide the x squared from both of these. Now if I divide the x squared, we're going to get 5x cubed divided by x squared is going to be 5x, minus 2x squared divided by x squared is just going to be 2. Now we got to do the exact same thing on these two terms, but now keep in mind right here, 30 and 12, both of them can be divided by 6. But one little thing is that keep the following in mind. Anytime the number or the value in my first term has a negative, you also need to factor out that negative. Okay, so we're going to factor out a negative 6, a minus 6 from both of them, and I have to divide them by negative 6 right here to see what's left from this polynomial, and we're going to get negative 30x divided by negative 6 is positive 5x, and 12 divided by negative 6 is negative 2. Now, from the original 4 terms that we had, now if you keep an eye on this, is now, since this is a multiplication right here between these two, the parentheses and the x squared, this is considered to be one term as a whole, and this one is considered to be another term as a whole. And what do we notice from those two terms is that both of them have a 5x minus 2, right? So what we can do again is that we can factor another greatest common factor, and that would be the 5x minus 2's. And again, if I factor the 5x minus 2's to determine what's going to be left right here in this parentheses, we gotta divide the 5x minus 2 from these two terms. And what's going to happen if I divide the 5x minus 2 from these two terms? It is going to cancel, it is going to divide out, right? It is going to reduce. So then what do we have left inside of this parenthesis is x squared minus a 6. Okay. Later on in this section, we're going to learn how we're going to, when is it that we can factor more, because there are expressions that we can factor more than once, and that's what we're going to learn throughout the process. Okay. Now, let's go through the next type of problems. Now we're going to be factoring trinomials. Now, for trinomials, we can also factor this by grouping, but I'm also going to show you a different method. The book, if you go through the book, the textbook, it's going to show you how to factor these trinomials by trial and error. Now, that method is not highly effective, so which can be done whenever you don't have any other choice or whenever you get stuck. However, it's not the most effective method. So what I'm going to show you is to factor the trinomials in two different ways. First of all, let's go ahead and factor it using the same strategy that we just did on the previous question, which is by grouping. Now, for trinomials, number one thing that you gotta do is this, that you need to multiply a times c. Now, the trinomials will be represented in this format, ax squared plus bx plus c. Okay, so a and c would be basically on this quadratic trinomial, which we call it because of the a square, is the a would be the number in front of the square and c would be the constant. So if I multiply these two numbers, that's going to give me a 90. So this is what you need to do. This is how you read this problem, okay, whenever it comes to a trinomial. You are trying to find two factors of 90, meaning two numbers that when multiplied they give you 90. And then if you look at the last sign, this sign tells you basically that if it's a minus, means that when you subtract them. If that sign would be a plus, means that when you add them. Okay, so you're looking for two factors of 90, that since that one is a minus, that when you subtract them, the answer is going to give you a 9 as an answer. So that would be, if you go through the factors, so you have 1 and 90, but 1 and 90 do not subtract to 9. 2 and 45 do not subtract to 9. 3 and 30 do not subtract to 9. Then you got 5 and 18, that does not subtract to 9. And 6 and 15, 15 times 6 is 90, but 15 minus 6 is going to give you a 9. Right? So those are the factors. So, but just keep in mind that it has to give you a negative 9 as an answer, so it has to be negative 15 and positive 6. So, what you're going to do is, you're going to make this trinomial into a 4-term polynomial. Now, the 45 and the 2a squared are going to stay the same right here, but the 6 and the 50, the negative 9a, you're going to change it into the two factors that we got here, which is the negative 15a and the positive 6a. That is the same as negative 9a. But now, if you notice, now we made this into a 4-term polynomial, which now, what can we do is, we can factor this polynomial by grouping again. So, I can group these two terms again, and I can group these two terms again, and all we gotta do is get the greatest common factors. From the first group, as you can see, we cannot factor anything from 2 and 15 other than 1, but we can take out an a. So 1a would be my greatest common factor. So we're gonna take out that a, and we're gonna divide the a from both of these terms, and that's gonna give us what's left. It's gonna be a 2a minus a 15. Now, from the other set of terms right here, we can factor from 6 and 45. We can divide them both by a 3, right? So, we're going to take out that 3 right here, positive 3, and then we're going to divide out the 3 from these two terms, and look at what we're going to have left. 6a divided by 3 is 2a, minus 45 divided by 3 is a 15 again. Once again, you see that we ended up with two terms. This is one term, and this is another term. Because of the multiplication, that becomes 1 and that becomes 1. So both of them have also a greatest common factor, right? We see that both of these terms have a 2a minus 15 in common. So I'm going to say right here that once again my greatest common factor is 2a minus 15. So then what's going to happen here is that we're going to factor that 2a minus 15. But then to know what's left over, we're going to divide both of these terms by the 2a minus 15. And what's going to happen to the 2a minus 15 is that it's going to simplify on both of them. So what we have left on the other parenthesis is the a plus 3. And these are the two factors for this trinomial. Now, I'm going to show you basically the other method that I usually use when factoring a trinomial. It starts very similarly as this one. We call it the AC method. That's exactly what I wanted to show you in this lecture. Now, to factor a trinomial using the AC method, so I'm going to put that title here. And this is the one that I want you to get most familiar with, is that you're going to do the following. You're going to multiply A, which is the first number, times the C. Basically, you start out the same way as with the grouping one. Okay? Multiply A times C. That gives you a 90. Again, you need to find two numbers that when multiplied they give you a 90, and based on the last sign, that last sign, since it is a minus, means that when you subtract those two numbers, the answer is going to be a 9. So it's going to be a 6 and a 15. Right? Once again, and again, since it is a negative 9, the biggest one must be negative, so it's negative 15 and positive 6. I want you to keep an eye on the following. You see that whenever we factor the trinomial, we ended up with two sets of parentheses on the left side right here. So, what does that mean? That anytime we factor a trinomial, this is what we're going to end up with. So on the AC method, that's what we're going to put, two sets of parentheses. Now, on the front, you see that we got an a squared. So what you have to do is you're going to divide it evenly. You're going to put 1a and 1a on each parenthesis in the front. Okay? And then we're going to take care of the 2 at the end. So I'll show you what you're going to do. Then from the two factors that you got, which is the 6 and the 15, it doesn't matter which one you put first as long as you put the correct signs. Now, I can put up, let's say, a positive 6 and a negative 15. Remember, the 15 must be negative because the answer right here, the 9, is negative. So the biggest one must be negative. Okay? Now the question is this. What do we do with the 2 that is in the front of the a squared? And this is what you're going to do. You're going to divide both of these factors by that 2. And what you're going to get is this. 6 divided by 2 is going to give me a 3. So this is going to give me an a plus 3. And look at the second factor. 15 divided by 2, that one is going to give me a decimal. So what does that mean? You're going to keep it as a fraction. Just make sure that this fraction has to be simplified. Can I simplify 15 and 2 by any number? The answer is no, right? We cannot simplify it. So after you check that it's simplified, the last thing you're going to do is the denominator from this fraction, you're going to move it in front of the variable. So that's going to be a 2a minus 15, which if you look at, it is the exact same thing as this. We just have them in the different order, but the factors are exactly the same. Now, the next thing I'm going to show you is how you're going to factor differences of two squares. This is a formula that I want you to keep in mind. This is used basically when you have a polynomial with two terms. Okay? This is going to be for two terms. There are several formulas that I will show you today that you're going to use to factor polynomials with two terms. Okay? So, this is the first one. A squared minus b squared equals to a plus b times a minus b. Now, the only thing we got to find out here is what's a and what's b. To find a and b, we need to find out something that when squared gives me the first term and something that when squared gives me the second term. That's what a and b will actually be. So, let's go through the first question here. It says, factor the following differences of two squares. The problem is x to the 4th minus 256. Okay? So, first thing we gotta do is we need to find out something that when squared gives me x to the 4th power. Okay? And we also need to find out something that when squared gives me 256. In this case, if I square an x squared, it's going to give me x to the 4. Keep in mind that this is one of the rules of exponents. When I raise a power to a power, the powers multiply. So that's going to give me my x to the 4. Likewise, we need to find out right here something that when squared gives me 256. And 16 times 16 is going to be 256, so that would be 16 squared. So, based on the formula, remember the formula for difference of squares is a squared minus b squared equals a plus b in one factor and a minus b in the other factor. So we already got a and b, you see? This is a squared minus b squared. So a is x squared and b is 16. So if we put them in the parentheses, this is how my answer is going to look like. It's going to be a plus and a minus, and in the first parenthesis is a plus b, which is x squared plus 16, and on the second parenthesis is a minus b, which is x squared minus 16. Remember that a is x squared and b is 16. Now, the next thing, this problem we are not finished because for one reason. You see that again, if we look at the second parenthesis, we have the formula again. We have a set of squares one more time. If this is going to happen sometimes, that you can have what we call repeated factorization. That's something we're going to have to check, and I'm going to show you a strategy, as a summary at the end of the lecture. So, this second set of parentheses, you see that we have a minus. The first one cannot be factored because there's a plus right here. So whenever you have two squares, but there is a plus in the middle, that is automatically prime. So this parenthesis cannot be factored anymore. Now, on this one, we need to find out something that squared gives me x squared, and something that squared gives me a 16, which in this case, x to the second power would give me x squared, and in this case would be 4 to the second power would give me a 16. So we're going to use the formula again, and the formula says a plus b and a minus b, and now the a is my x and the b is the 4. This is a squared minus b squared, x squared minus 4 squared. So that means that my solution for this will be a, which is x, plus b, which is 4, times a, which is x, minus b, which is 4. And don't forget to bring the other factor down, which is the x squared plus 16. And this concludes this problem. We cannot factor anything else. Okay, now we have another set of special formulas that we use to factor polynomials with two terms, and that is sums and differences of two cubes. So I'm going to go back to this one. So these are two formulas that we're going to use next with sums and difference of two cubes. A cubed plus b cubed equals a plus b in one parenthesis, and a squared minus ab plus b squared in the second parenthesis. Now, if I have a difference of two cubes, a cubed minus b cubed, then you factor it like this: a minus b in one parenthesis, a squared plus ab plus b squared in the second parenthesis. Now, keep in mind that the only thing we gotta find out is what is a, what is b. In this case, how do we find a and b? Basically, by finding something that when cubed gives me the first term, and something that when cubed gives me the second term. That's how we find a and b. Okay. Let's get into this question right here. Factor using the formula for sums and differences of two cubes. So, first thing is 27x cubed minus 1. So what we have to find out is this. We need to find out something that when cubed, or something that when multiplied 3 times itself gives me 27x cubed, and something that when multiplied 3 times itself gives me 1. What can I multiply 3 times itself that would give me a 27x cubed? It would be a 3x. 3x times 3x times 3x is 27x cubed. So 3x cubed, right? And what do I cube that will give me a 1? 1 times 1 times 1, so it would be 1 cubed, right? So we already got the a and the b. You see, this is a cubed minus b, which is this, cubed. So according to the formula says this. I'm going to write it down. A cubed minus b cubed equals a minus b in one parenthesis, a squared plus a times b plus b squared in the second parenthesis. So we already know that a equals 3x and b equals 1. So let's put it in the formula right here. Okay. I'm gonna set it up. So everything's ready. So a minus b would be 3x minus b, which is 1. Then the second parenthesis, a squared, meaning 3x squared, plus a, which is 3x, times b, which is times 1, and then plus b squared, which is plus 1 squared. All we gotta do is simplify that second parenthesis. So 3x times 3x is gonna give me a 9x squared right here, plus 3x times 1 right here, it's gonna give me a 3x, plus then 1 squared is gonna be a 1, and these are my two factors for this expression. Now, one little observation that I want you to notice is this. We ended up with a trinomial in the second parenthesis. It doesn't matter what kind of trinomial you get right here on this parenthesis. That trinomial, whenever you do the difference of two cubes or sum of two cubes, will be prime, meaning that it cannot be factored. So this will be the end of the story. Now, we're going to do one more special formula. That one is a special case of trinomials. We call it a perfect square trinomial. So I'm going to go back to that before we do the last problem. This is a special type of trinomial that you're going to notice right here. It is a formula that we can use. So it tells me that sometimes it could be that the trinomial is going to give me the same factor twice. Okay, how do we find out if a trinomial is going to give me the same factor repeated 2 times? Basically, it's by doing the following. All I need to do is find out if the first term is a square, meaning that if I can find something that when squared gives me the first term. Also, I need to find out if I can find out something that when squared gives me the last term, which is the third one. And then I gather those two terms and I multiply them by 2. Multiply those two terms and then multiply the answer by 2 and check if that gives me the middle term. If it does, then we can write that down as a square, which means a factor repeated 2 times itself. And all we gotta do, the only thing important is look at this sign. That sign is gonna be carried over to my factor. Okay? And you see if this one has a minus, that minus sign is gonna be carried over to my factors. So I'm going to show it to you with the formula, and then I'm going to show it to you using the AC method so that you compare that it will actually give us the same result. Okay, so let's factor it with the formula. Factor the perfect square. Okay, now with the formula, this is what you got to do first. You need to find out if you can find something that when squared gives me the first term and something that when squared gives me the second term. And right here it would be 6x times 6x would be 36x squared. Likewise, 1 times 1 is going to give me 1, so 6x squared and 1 squared. Now, the last part of the rule tells you the following, that now you need to put them together. You need to multiply that 6x times that 1, and then what you need to do is you're going to double that result. And if that equals to the middle term, then that means that this is in fact a perfect square. That's how you actually recognize a perfect square trinomial. So you see that right here, 6 times 2 times 1 is going to be 12x. So that one is actually a perfect square. So then you're going to write the answer like this. You're going to put a parenthesis square with this sign in the middle. You're going to bring it down. You're going to bring down the first term. You're going to bring down the last term, and with the square at the end. So that would be a 6x minus a 1 squared, meaning that you get the same factor 2 times. 6x minus 1 times 6x minus 1. Those are the factors for that trinomial. Next, now I'm going to show you also how we can actually factor it also using the AC method or by grouping, whatever you prefer. So this can also be done like that. If you cannot recognize this being a perfect square, or you forget the formula for the perfect square trinomial, then you can also work it out using the AC method. That's what I'm going to do next. Okay. So for the AC method, remember the way we started is that we're going to multiply A times C. 36 times 1 is a 36. So we gotta find two numbers that when multiplied give me 36, but at the same time, if you look at the last sign, that means that when added, they give me 12. So that would be 6 times 6. But since it is a negative 12, both of them must be negative and negative, because they need to add up to negative 12. So we're going to put the negative 6 and the negative 6 on these two factors right here. And then don't forget that this x squared, you're going to break it down evenly. You're going to put 1x on each parenthesis. And what do I do to the 36? Just like I showed you, is you're going to divide both of them by 36. So 6 and 36, 6 cannot be divided by 36. So remember what I told you you're supposed to do if you cannot divide? You have to see if you can simplify them. And actually we can, right? 6 and 36, both of them can be divided by 6 here, and 6 and 36, both of them can be simplified or reduced by 6. So you see what we're going to get. X minus 1 over 6 in this factor, and x minus 1 over 6 in this other factor. Then after you reduce it, what do we do to the denominator? You bring it in front of the x, right? That will be a 6x minus 1 and a 6x minus 1. Then since you got the same factor repeated 2 times, what do? We're going to write it just 1 time, but with the square at the top, which is basically the same thing as this factor. A little bit longer with the AC method, but we still get the same solution. Okay? So if you can recognize a perfect square when you see it, then you can go ahead and use the formula, okay? Which is a lot shorter. Now, I'm going to give you a little summary. So to complete this section, this is a little summary that you need to keep in mind of how you factor polynomials, okay? So the first thing that you gotta do all the time that you see a polynomial that it doesn't tell you, of course, in the future it's not gonna tell you how to factor. You're going to have to come up with the idea yourself. First thing that you always have to do is factor out the greatest common factor. Now, if it doesn't have a greatest common factor, then you skip that. But you always have to check for that first. Okay? If there is a problem that has a greatest common factor and you forget to do it, then the problem is going to be wrong from the start. Second step in the process. Now, the second step in the process consists of 3 things. Okay? What strategy am I going to use to factor the polynomial? And that is very simple. And that is based on the number of terms that the polynomial has. So if the polynomial has 2 terms, then you have to determine which one of these formulas can be applied. If you can write them as squares or if you can write them as cubes. You use either one of these, whichever one is applicable. Now, what happens if the polynomial has 3 terms? Then you're going to see if it is a perfect square trinomial. That you can go ahead and do it if you want to. Now, or you can skip over to factor with the AC method. I don't suggest you don't do it by trial and error, which is what the book uses. So what I suggest is that you use the AC method, or you factor it by grouping, whichever one is best for you. Okay? That happens if it has 3 terms. So check if you factor it using the AC method, or factor it if it's a perfect square and you can recognize that, use the formula. Whichever one applies best to you. And the last thing is, what if it doesn't have 3 terms? What if the polynomial has 4 or more terms? Then you factor it by grouping. That's basically the second step in this strategy. After you find the GCF, depending on how many terms the polynomial has, that's the strategy you're going to use to factor. And the last step in the process is this. Keep the following in mind. If your polynomial still contains squares or cubes or any other types of exponents that are not linear, meaning that are not just x to the first power, you have to check if the polynomial can be factored further. Okay? That's what you gotta do. So let's go ahead and do a couple of problems on this strategy and see what if you can understand what to do first, what to do next, and what to do last on each one of them. Let's start with this. We're gonna factor completely or state that the polynomial is prime. So the first step in the process right here, like I told you, is that you need to find out if there is a greatest common factor. That is the first step in the strategy. And in this problem, as you can see, both of them can be divided by 2, and I can take out 1x from both of them. So I'm going to factor a 2x from this expression, and what you gotta do is divide the 2x from both of them. So if I divide the 2x, we're gonna end up with x squared for the first parenthesis, minus 72x divided by 2x is minus 36. Second step. Now, if you look at this parenthesis now, that has 2 terms, right? So, anytime you have a polynomial with 2 terms, keep in mind that there's 3 possibilities. It could be that it is a difference of 2 squares, a squared minus b squared, or it is a difference of 2 cubes, a cubed minus b cubed, or it is a sum of 2 cubes, a cubed plus b cubed. In this particular problem, we see that both x squared and 36, they're both squares. So the first formula is the one that is going to apply to this problem. So the formula is a plus b times a minus b. All we gotta do is find what a and b are, which means something that when squared gives me x squared, and something that when squared gives me 36. That would be x and a 6. So a squared minus b squared, x squared minus 6 squared, the factors will be a, which is x, plus b, which is 6, times a, which is x, minus b, which is 6. And don't forget, bring down the greatest common factor, 2x. Step number 3 and last. Can we factor this polynomial further? And basically the key to determine if you can factor it further in the first place is you gotta determine if your polynomial still contains squares or exponents in the x's. And as you can see, these 2 parentheses, both of them are what we call linear. Linear means x to the first power. So that means you cannot factor any further, so this is my final result. We are finished. Let's do a couple of more problems. Now, let's work on this. Factor completely, x squared plus 144. Now, this particular problem, I want you to look at it very carefully. If you look at this, greatest common factor, x squared and 144, the only thing you can factor is a 1, nothing else. So that means there is no greatest common factor that can be factored from this. Step number 2, it has 2 terms. So remember, on the second step, based on the number of the terms, that's going to tell you how you're going to factor it. So that means if it has 2 terms, it could be that it is a difference of 2 squares, or that it is a difference of 2 cubes, or that it is a sum of 2 cubes. The only possibility, because of the sign, as you can see, it is this one. The other ones are differences, right? So what does that mean? I need to find out if I can write this, find out something that when cubed gives me x squared, and something that when cubed gives me 144, and as a surprise, there's nothing that we can find out that cubed gives me x squared, and that cubed gives me 144. None of them. So, in this problem we are stuck. And this is basically something that I mentioned to you before. This looks like 2 squares, but there is a plus. And I told you this, that anytime there's a sum of 2 squares, that polynomial is automatically prime, meaning that I cannot factor it out. Okay? So none of these things are going to work. And no greatest common factor either. Okay. Let's do one more question. This is going to be my last question for this section right here. We're going to factor the expression completely or state that the polynomial is prime. Now, number one thing that we got to do again is that we need to find out if this polynomial has a greatest common factor, which in this case, if we look at all of the terms together, x cubed, 5x squared, 4x, and 20, all of them, they can only be divided by 1, and there is no x's in common. So there is no greatest common factor other than 1. So next thing is based on the number of terms, that's what you're going to use. Since this one has 4 terms, then the strategy that we use is we factor by grouping. Okay? So we're going to put it into two groups, and what we need to do for each group is that we need to factor the greatest common factor from each one of these two groups. From the first group, we can factor a 1 from the 1 and the 5, and also two x's. So it's 1x squared, which is just x squared. So we're going to take out that x squared, and what we got to do is we need to divide both of these terms by that x squared. And if I divide them by x squared, we're going to be left with x plus a5. Now, we have to do the same thing for the other ones. We need to find out what can we factor from 4 and 20. Both of them can be divided by a 4. But remember what I told you, if the first term is negative, then you also have to factor that negative. So that would be a minus 4. So then if I divide the minus 4 from both of these terms, then we're going to be left with x plus a5. We're not done with the grouping yet. So this part is going to be all grouping. Okay. The next thing is that, as you can see, we have another greatest common factor, x plus 5 and x plus 5 from these two terms. So then we're going to factor the greatest common factor of x plus 5. Okay. So we're going to take it out from both of these. And when I factor it, we need to find out what's left. And to find out what's left, we need to divide that greatest common factor of x plus 5 onto both of these terms. So that's going to simplify both of the x plus 5s here. So we're going to be left with x squared minus 4. Okay. Now, last step in the process is we have to determine, step number 3, if we can factor this further. Which in this case, we can, because as you can see, if you look at the second parentheses, we ended up with two terms. So let's put that information so that you remember that. We ended up with two terms, and both of them are squares. For two terms, we got three formulas. Remember, a squared minus b squared, a cubed minus b cubed, and a cubed plus b cubed. So the one that applies to this problem is the first formula, which is a plus b times a minus b. So all we gotta do is find a and find b. So what's a and b? We gotta find something that when squared equals to x squared, and something that when squared gives me 4. And that would be x, and that would be a 2. Right, so that's what we're gonna put here, x and 2. So then we're going to factor this into a plus b times a minus b. Remember that a is x and b is 2. So my factors would be a, which is x, plus b, which is 2, times a, which is x, minus b, which is 2. And then bring down the greatest common factor. And can we factor it even further more? No, because all the factors are linear, x, x, and x. This is the end of this problem. Okay. So this is going to be the end of section P.5.